We want to evaluate the integrals below by interpreting it in terms of areas in the figure, where we can model a def integral as area bounded by the function in the x-axis, as long as we recognize that if the area is above the x-axis, the value is positive. If the area is below the x-axis, the value is negative. So looking at our figure here, notice how these two areas are above the x-axis, and therefore on the interval from 0 to 2 and the interval from 4 to 5, the value of the def integral would be positive. But notice on the interval from 2 to 4, the area is below the x-axis, and therefore the value of the def integral would be negative. So looking at our first example, we have the integral of 2 times f of x from 0 to 4. So the first thing we want to do is take advantage of our property of def integrals and factor out this 2. This is equal to 2 times the def integral of f of x from 0 to 4. So to evaluate this, we would have 2 times the value of our integral from 0 to 4, which should be over this interval here. Well, notice on the interval from 0 to 2, the value of the def integral would be positive 2 because the area is above the x-axis. So we'd have 2 times the quantity 2. And then on the interval from 2 to 4, notice how the area is 5, but it's below the x-axis. And therefore the value of the def integral of this interval would be negative 5. So we'd have 2 either plus negative 5 or 2 minus 5. This would give us 2 times negative 3 or negative 6. Now looking at our second example, the only change is we're now integrating from 0 to 5 instead of 0 to 4. Let's first rewrite this as 2 times the integral of f of x from 0 to 5. So we'd have 2 times the value of our integral from 0 to 5 over this interval here. So from 0 to 2 we'd have positive 2, but then from 2 to 4 we'd have a value of negative 5, so plus negative 5 or minus 5. And then from 4 to 5 we'd have a value of positive 2, again because the area is above the x-axis. So here we have 2 times, this would be negative 1, giving us a value of negative 2. I hope you found this helpful.